Today we're going to be looking at lesson 2 in our matter unit, and this lesson deals with the concept, the property of density. As we begin to talk about density, the first thing I want to do is just give you a very simple definition for what density is. And basically density is just a property of matter that shows a relationship between mass and volume. In lesson 1, we looked at the property of mass and the property of volume, and we said that mass measures how much matter is in an object, and volume measures how much space the object takes up. So basically, because density is showing this relationship between those two properties, it's telling you the amount of matter that's in a specific amount of space, or a specific amount of mass in a given volume. So we see here our example of a ball of iron versus a ball of cotton. And if we took two objects that were the same size, this ball of cotton, this ball of iron, the object that was less dense would have less mass if the volume's the same. So when we look at those, we know obviously, well, cotton is more lightweight than iron, right? It's a lighter material. If I picked up a handful of cotton versus a handful of iron, the cotton would weigh less. It has less matter in it than the iron, even though they take up the same amount of space. What you can think of with this is just in terms of these atoms, these molecules that make up a substance. They can be packed very tightly together, or they can be spread apart more. A good example of this might be the classroom. If we had 5 students in the classroom right now, they could spread out over a large area. Everybody could be several feet apart. They wouldn't be packed on top of each other. So we could say that the classroom was not very densely populated. But if we moved 100 people into the classroom, now they would have to kind of squeeze together, and there wouldn't be as much space to move around. People would be bumping into each other. If we squeezed 300 people in the classroom, we could do it, but they're going to be packed very tightly together. So you could say that the population would be more dense. There would be more students in a classroom, more matter in a given amount of volume. And that's the way density works, and that's the way we can think about it and measure it. The more tightly packed the atoms and molecules in a substance are, the more dense the substance will be. Now, we talked about measuring mass in terms of grams. We talked about measuring volume in terms of milliliters or liters. And if we know the mass and the volume of an object, we can calculate its density. And it's a pretty simple process, but again, density is the amount of mass in a given amount of space. So the unit that we use to measure this, it ties those other two units in. It's grams, the unit of mass, per cubic centimeter, which is equal to 1 milliliter, which is our unit of measure for volume. So we just say that the density of an object is measured in grams per cubic centimeter. Now, in order to make this calculation, we just have to use a little bit of division. And we know that math and science, a lot of the time they do go hand in hand. We need these math skills to be able to figure out things in the science classroom a lot of the time. So to calculate density, all we have to do is divide an object's mass by the object's volume. And we can look at an example here of a golf ball. If we know that a golf ball has a mass of 45 grams and it has a volume of 40 cubic centimeters, then in order to determine its density, all we have to do is divide its mass by its volume. So our division problem would be 45, the amount of mass, divided by 40, the amount of volume. And that gives us a density of 1.13 grams per cubic centimeter. Now what that means, we talked about a cubic centimeter being just a very small cube that's 1 centimeter long, 1 centimeter wide, 1 centimeter high. So if we took that 1 centimeter cube worth of golf ball, if you just cut a 1 cubic centimeter piece of golf ball out, that piece of golf ball would weigh 1.13 grams. That's the way that density works. It's not how heavy the object is overall as a whole, it's how heavy compared to other objects. How many grams are in that 1 milliliter or that 1 cubic centimeter of that substance. Water is something that we tend to look at when we talk about density and talk about grams per cubic centimeter, because water is essentially the standard for this measurement. Water has a density of 1 gram per cubic centimeter. And what that means is for every cubic centimeter of water, or every milliliter of water, because we said those are equal, those have a density, or rather those have a mass of 1 gram. So 1 cubic centimeter of water has a mass of 1 gram. Water has a density of 1 gram per cubic centimeter. Now, an important concept that relates to our study of density is the idea of buoyancy. And I've got a picture of a boat here because we think of boats as being buoyant. They float on water. And essentially what buoyancy is, it's just the property of a less dense material to float on top of a more dense material. Now, this could apply to liquids like water. It could also apply to the air in the room. A helium balloon is a great example of a less dense object floating on a more dense substance because the helium is very lightweight. It's not very dense. It has a very low mass compared even to the air around us in the room. So the helium balloon, as we inflate it and let it go, it rises up above the air. It's essentially floating on the air, which even though, we don't feel the air that much and we don't think of it as being dense, but the air in the room is actually more dense than the helium in the balloon. So the helium floats. The water is more dense than the boat, so the boat floats on the water. If for any reason the boat became more dense than the water, the boat would sink. Maybe we fill the boat up with water, the boat's going to sink because now it's more dense. So buoyancy describes an object's ability to float on another substance. And a great example that I can show you now of density and buoyancy has to do with a material that we've all seen before probably, aluminum foil. And aluminum foil, even though it's thin, it's flexible, it's lightweight, it's metal. It's aluminum. We could take, it's the same thing that a soda can's made out of, or we could just take a solid block of aluminum. But I'm going to take this aluminum foil and I'm going to make a ball with it. I'm going to make a ball that's not very dense. I'm not going to pack it together as tightly as I can. It's just very loosely packed. And I've got a beaker of water here. And we're going to place our aluminum foil in the beaker of water. And you can see when I place the aluminum foil in the water, even though this is metal, even though we don't really think about metal floating, this aluminum foil will float on the surface of the water because the molecules are spread far enough apart to make it buoyant, to make it less dense than the water. So in that case, we know that if the density of the water is 1 gram per cubic centimeter, and we know that the aluminum foil is buoyant, so it's less dense, we don't know the exact density of the aluminum foil right now, but we can say that the density of the aluminum foil is less than 1 gram per cubic centimeter. It's less dense than the water, so it's buoyant and it floats on top of the water. A second example I want to look at, though, is with an equal sized piece of aluminum foil. We have the same amount of mass that we had in the ball because the two pieces of aluminum foil that I used were the same size. But with this one, I'm going to make a more tightly packed ball. So I'm going to take this, I'm going to press it together as tightly as I can to make a very compact ball of aluminum foil. And I'm going to mash it against the table. I'm going to try to get the molecules of aluminum as close together in this ball as I can. So at this point, I've taken that 12-inch piece of aluminum, that 12-inch sheet of aluminum that was not very dense, and I've pressed it into the tightest, most dense ball of aluminum that I could. And you can see compared to the other one, it's got a little bit of water dripping off of it where it was sitting in the beaker, but you can see by comparison, this ball of aluminum foil is much, much smaller than the original, even though they have the same amount of aluminum foil in each ball, which means the smaller ball is more dense. The aluminum foil in this ball is packed more tightly together than the aluminum foil in the other ball. And I want you to watch what happens when I place the second ball of aluminum foil into our beaker of water. I'm going to leave the first one in there. You can see it's still floating. Even if I push it under the water, it pops back up because, again, it's less dense than the water. It has that property of buoyancy. But we're going to put the second ball of aluminum foil in here, place it on top of the water, and watch what happens as I place this in. And you can see that ball of aluminum foil sinks to the bottom of the beaker because, again, it's more dense. The molecules of aluminum are packed more tightly together in the second ball. So even though it's the same material, one piece floats and one piece does not. And again, we can go back to what we know about the density of water. We know that the density of water is 1 gram per cubic centimeter. So even though we may not know the exact density of that aluminum that we put in, we know that the second piece is more dense than 1 gram per cubic centimeter because it does not float, it does not have buoyancy on that water. The first piece we know has a density less than 1 gram per cubic centimeter because it is buoyant. So this is just an example of that idea of density and how it relates to practical applications. We think of boats and things that we build that need to float on water. We have to think about the density of the materials that we use, the density of the design that we build. But again, this idea of density is just this relationship between the mass and the volume of the object. In our next couple videos, we'll be looking at some more activities that we can do to study the density of different materials.